Hello, my name is Bryce Graham. I'm a PhD student in transportation engineering and a Master's of Arts student in urban and regional planning at the University of Florida. And today I will be elaborating on my ongoing research with the FDOT, where we are evaluating the operations and safety benefits of AI-driven driver information-focused countermeasures for CAV technologies. So anybody that has worked in traffic safety analysis in the state of Florida would be relatively familiar with the motivation behind this research, as we have a wealth of crash reporting databases, as well as a wealth of CAV deployments. Where our challenge comes in is evaluating the tangible safety benefits of these CAV deployments because we rely on this responsive process of traffic safety analysis, waiting for crashes to happen and be reported before we have statistics to evaluate them based on. So in this research, we develop a microsimulation model and employ surrogate safety assessments developed by the Federal Highway Administration to project potential safety improvements that can come from connected and autonomous vehicles. So we employ the Aim Soon Next microsimulation software, first constructing a baseline simulation model and using the city of Gainesville's existing signal timings, as well as OpenStreetMap and other sources to try to get a model that as accurately as possible represents existing conditions, comparing operations to some highway capacity software analyses. Once we have this baseline model set up, we then push the limits of Aim Soon Next to try to see what kind of safety messages we can send to vehicles. What this resulted in were speed control strategies that replicate both DSRC and CV2X communications, as well as three different types of CVs that we modeled. We modeled two different types of CAVs that have adjusted car following models and improved reaction times, as well as CVs that are basically human-driven vehicles that are required to slow down within the speed control zones. So we know that our DSRC units can communicate roughly 1,000 feet from our intersections. So we first implemented a local speed control strategy at 2 locations on our modeled corridor. Then for more of a CV2X application, we modeled a corridor-wide speed control that requires the CAVs or CVs to slow down by 10 miles per hour anytime they're within one of these links in the microsimulation model. Once these models are run, they're then exported to this Federal Highway Administration software that reads in all of these TRJ files that track the vehicle's trajectories through the simulation and identify conflicts. What we found was that for the CAVs with adjusted car following models, we saw a significant reduction in conflicts, but for the CVs that were driven like humans, the additional friction and speed actually created more conflicts on the roadway. Thank you so much, and please reach out with any questions.